Today's lesson is 4.3 day 1 and it's the first derivative test. So you're going to learn about what the first derivative test is and how to understand a function using it. A lot of this we have actually already used, so don't be surprised if you're saying to yourself, I already know this, because that's good if you can say that. Anyway, the first derivative test, there are 5 points on page 205, 206. It goes into much more detail there. Please read those. The basics about finding local extrema is number 1, find the critical points. Find the critical points and see if the derivative is positive or negative in each interval. Okay, so you put together your little interval chart. Here's what you do with the critical points. Number 1, if it goes from positive to negative, it's a max. If it goes from, number 2, if it goes from negative to positive, it's a min. If the derivative doesn't change, then there's no local extreme value at that point. We'll talk about what that might be later. Then, after you get done checking the critical points, you check the end points. And we talked about at the left end point and the right end point, but there are some good pictures in your book. Please read these. I can't do justice to it right now quickly, so please look at page 205, 206. On the left, remember, if it's positive, then this is a min. If it's negative derivative, positive derivative, negative derivative, then this is a max. Okay, and the opposite is true on the right. Okay, on the right, you have an increasing function, you get a max. Okay, that's plus. You have a decreasing function, you get a min. That's on the right. Okay, so positive and negative indicate the derivative signs. Okay, so let's use this first derivative test to figure out local extreme values. First thing we're going to do is take the derivative of y. We have negative 6x squared plus 12x. Second thing we want to do, we're going from negative 3 to positive 3. Let's figure out where this equals 0. Well, let's see. We can factor out a negative 6x and get x minus 2. Negative 6x squared plus 12x. Okay, then that tells us if we set both of these equal to 0, that tells us that at x equals 2, we have a critical point, and at x equals 0, we have a critical point. So let's set up our intervals. Negative 3 to 0, 0 to 2, and 2 to positive 3. Okay, so what is the sign on each of these? Sign of the derivative on each of these. All right, well, this is your derivative on negative 6x, x minus 2. Maybe that form is easier for you to plug in. If that's a negative number, then we have a negative here, it's positive here, it's negative here. You have to plug numbers in these intervals into the derivative equation to find the sign. That means this is decreasing, this is increasing, this is decreasing. Okay, next thing we're going to do is find our actual points. Okay, so we have a critical point. Actually, we're going to have an extrema right here. Negative 3 something. Here is 0 something. We're going to figure out the y values in a minute. And 3 something. Okay, so those are our 4 points we want to determine if they're minimums or maximums. Now, you have to take this actual y function and where is the column, maybe? Okay, let's bring that down here. You're going to use this formula to figure out the y values. Okay, people always get these. This one right here, you use the derivative formula. Down here, you use the function formula, f of x or y. All right, and that's where you get these numbers right here, all of your y values. Okay, I'm not going to take the time to plug all these in, but if you plug this in, oh darn, it's like 105 or something like that. Anyway, I forget what the exact number. You can figure it out and tell me tomorrow. what the number was, 2, 5, negative 3. I just can't read my paper. It's 100 and something. So those are your y values. We plug them into here. All right, next we want to find out if these are minimums, maximums. Because we have a closed interval, a continuous function, and a differentiable function, we know that we are going to have at least one absolute max and at least one absolute min. And now, using our y values, we're going to be able to tell which one is the absolute. All right, so here we have an endpoint, and the function is decreasing after it. That means this is a max. All right, we're going from decreasing to increasing. So right here is a min. We're going from increasing to decreasing. I always draw these little diagrams. You don't have to if you can remember this, but it just helps me. All right, and now I have a decreasing to a right endpoint. That means this is a min. Okay, so I have max, min, max, min. All right, so let's look at our two maxes. Our two maxes have y values of 100 and something and 5. Therefore, this is our absolute max because 105 is bigger than the y value of 5, and this is a local max. All right, our two minimums are equal. Therefore, they are both absolute or global maximums over this interval. All right, and those are our absolute minimum, absolute maximum, absolute minimum. We have two of them. We had to have at least one, but we have two. All right, next problem. Use the first derivative test to find the local extreme values. This one's a little bit more intense only because we have to use the product rule to take the derivative. So it has just a little bit more labor applied to it, but we're not afraid of hard labor. Okay, that's a 1/2. So I'm going to take the product rule. All right, you take the product rule, and what do you get for the derivative? You set u to this, v to that. You get the u v prime plus v u prime, and you get x squared over square root of 4 minus x squared, and plus square root of 4 minus x squared. And I'm putting that over 1 because I'm going to combine these two terms. This is what you get when you do the product rule, but we need to combine these two terms. So we're going to multiply the top and the bottom by the square root of 4 minus x squared. All right? So what we're going to do is get a common denominator here so that we can put these two together and figure out where the derivative is 0 and where the derivative is equal or doesn't exist. All right, so we have a common denominator once we multiply the second term by square root of 4 minus x squared over square root of 4 minus x squared. So our common denominator is this. And we have x squared. Actually, I think this is minus x squared. I'm positive it is. Minus x squared plus 4 minus x squared. All right, so if I simplify this top, I get minus 2x squared plus 4. All right, now, going back to some of our Algebra 2, maybe pre-calc, if the denominator equals 0, that would mean that our derivative does not exist, correct? If the top equals 0, that means that the derivative equals 0. So we're going to check both of these cases. Now, when we do this, especially the bottom, we set the bottom equal to 0, we get x squared equals plus or minus 2, or x equals plus or minus 2. But really, that is actually going to be our interval because you cannot have a negative under the square root sign. So these are not only critical points, but they are going to be our endpoints as well. Okay, so this is where the derivative does not exist. I set the denominator equal to 0. If we set the top equal to 0, negative 2x squared plus 4 equals 0. In this case, we subtract 4 from each side, we divide by negative 2, we get a 2. We get x squared equals 2. And if we take the square root of both sides, we get x squared equals plus or minus square root of 2. All right, so those are our two critical points. The derivative equals 0 and x equals plus or minus square root of 2. All right, let's set up our intervals. Negative 2 to negative square root of 2. Negative square root of 2 to positive square root of 2. And the last interval is square root of 2 to 2. I know I'm doing this kind of fast, but we should somewhat know this part already. Okay, the next step is going to be calculating the sign of the derivative. All right, this back here is our derivative. All right, that's our most simplified derivative. The denominator can never be 0, or it can never be negative, so it's always going to be positive. Therefore, negative 2x squared plus 4 is going to determine the sign of our derivative. Okay, the sign of the derivative, which is this middle row. So we're going to take numbers in between each of these intervals and plug them into the derivative, the numerator of the derivative, to see whether they're positive or negative. In this interval, they're negative. In this interval, they're positive. And in this interval, they're negative. You have to take a number between square root of 2 and 2. Or you could put it in your calculator and see what happens when you have, 1.8. This derivative will be negative. All right, that means this is decreasing, increasing, and decreasing. Okay, now we're going to have 4 points. So now we're going to figure out our points, our endpoints, and our critical points, and see if we have maximums or mins or what they are. And again, we have a closed interval from negative 2 to 2. That's actually the domain of this function. So as long as we have that closed interval, we are guaranteed an absolute min and an absolute max. Here we have negative 2 something. We're going to use our y function to figure out what that is. We have negative square root of 2 something. These are the points. Square root of 2 something. And 2 something. Okay, so now we need to figure out our y values. Plug each of these 4 numbers into the function. Well, we get 2 zeros here at the beginning and the end. And we have a negative 2 here and a positive 2 here. Now we need to determine if these 4 points are maximums or mins. Okay, we start here at the left. We're decreasing. That means this is a max. We're decreasing, then increasing. This is a min. We're increasing, then decreasing. This is a max. And we're decreasing down to a point, therefore this is a min. All right, let's compare our 2 maxes. We have a y value of 0 and a y value of 2. Therefore, this is the absolute max. On our mins, we have a negative 2 min and a 0. Therefore, this negative 2 is our absolute min because it's lower than the 0. These other 2 are locals. And there you have our maxes and mins. Next, we're going to talk about a concavity test. Anywhere that the second derivative is greater than 0, it's concave up. And where the second derivative's less than 0, it's concave down. What do we mean by that? Concave up means your graph is opening up. Concave down means the graph is opening up downward. Okay, so concave up looks like this, concave down looks like this. Anyway, so we check the second derivative and see the sign of the second derivative. All right, so we're going to take two derivatives to figure out the concavity of this function. We have the derivative equals 0 minus 3 times cosine of x. Okay, the second derivative equals, cosine is positive sine, so we have plus 3 sine of x. All right, so we are going to check the second derivative. First thing, we're going to set this equal to 0 to figure out what intervals the second derivative might change. Okay, wherever this is equal 0, it's probably going to change signs. So sine is 0 at x equals 0 and x equals pi, right? Sine is 0. So we're going to make two intervals. We have 0 to 2 pi here. One from 0 to pi, and the second one from pi to 2 pi. Okay, so these are our two intervals. This time we're going to check the sign of the second derivative because it's not asking us about critical points or anything like that. It's asking us about concavity. So we're going to check the sign of the second derivative, which is 3 sine of x. From 0 to pi, that sign is positive. From pi to 2 pi, that sign of sine is negative. So from 0 to pi, we're talking concave up. And from pi to 2 pi, we're talking concave down because it's negative. Okay? It's a pretty kind of simple concept, sort of. All right, let's do it one more time to find concavity of this interval. So once again, we take the second derivative of this, set it equal to 0, and see where it changes sign. So first derivative is x to the negative 4/5 times 1/5. Okay, the second derivative equals negative 4/25. And then we're going to subtract one more from here. So x to the negative 9/5. All right. The only place that this derivative equals 0 is at x equals 0. Or doesn't exist. It's only at x equals 0. And our interval is 1 to 4. So from 1 to 4, what is the sign of the second derivative? Well, it's always equal to a negative because we have a negative right here. So if the second derivative is negative, that means that this function is concave down between 1 and 4. Okay, so that gives you a little idea about concavity test and first derivative test. Have at those problems.